Hello everyone, my name is Mr. Guajardo, and today we're going to be going over how to get linear equations from either a point and a slope or two different points. Now let's go over what I mean by linear equations. There are three different forms. The standard form, ax plus by is equal to c. Point slope, y minus y1 is equal to m times the parentheses of x minus x1. And the one that we're all familiar with, slope-intercept form, y is equal to mx plus b. And it's color-coded in a way such that when I introduce vocabulary like m is equal to slope, you could correlate that to a specific form. Like for slope, it's going to be point slope and slope-intercept. For constant, it's going to be in standard form. And for b, which is y-intercept, it's going to be in the slope-intercept form. Now don't get me wrong, b and c are both constants, but just to give a little bit of uniqueness to both of them, I'm going to do that. And we're going to be able to find out and translate each one of these, given either a slope and a point, or two different points. Now it's important to note the formula for slope because we could use two different points to give us the first situation. And I mean that by just having a slope and a point, we could instantly apply this to the point slope form, as all we need is a slope and a point, and then we have it done. And we could easily translate the point slope to slope intercept and then slope intercept to standard form. Simple as that. So we're gonna work with until we get just a slope and a point. And how are we going to do that if we have two different points? Well, let us recall that the slope formula is a change of y and the change of x, meaning, and something more familiar, y2 minus y1 is equal to x2 minus x1, that giving us a slope, and only being able to do that when we have two different points. We could then apply the new given slope and either the first point or the second point and apply that to the point slope form. And from that, it's smooth sailing from there. So let us get to reviewing. Let's get some examples out the way. We're going to start off with something a little bit simple. So just to go over, let us start off with just having 2 points of 0, 0 and 1, 1. Let's just say this is going to be our x1, y1, x2, y2. And let's apply the slope formula as we had just mentioned. So we're going to have y2 minus y1, or 1 minus 0, over x2 minus x1, which is going to be the same thing, 1 minus 0. And then later, we just simplify, which is going to be 1 over 1, or it's just going to be 1. And that's going to be our slope. And now that we have that, we could apply that to the point slope form plus any of these points. We could do 0, 0, 1, 1. Does not matter. In fact, I'll go ahead and do both. So we just do y minus, let's do the first point first, 0 is equal to 1 times x minus 0. And then later, which will give us y is equal to x. We do not mind, or we do not rewrite the 1. It's going to be a little hidden number. And now the same thing, y minus 1 is equal to 1 x minus 1, which is pretty much going to be the same thing, x minus 1, just subtracting 1 from both sides, which these equations are equivalent to each other, and they're also both in point slope. But about this equation, it's also in slope-intercept form with b being 0, and we could easily make this into slope-intercept form as well by isolating the y. So by adding y to, or 1 to both sides, we get y is equal to x. Same thing, plus 0. That's going to be our b. Now it's slope-intercept form. So they end up the same thing. And then later, to translate that one more time, we're going to now put that into our standard form, which is going to be, we're going to subtract x from both sides to have x and y at the same side. Negative x plus y is equal to 0. And that means our a is equal to -1, our b is equal to 1, and our c is equal to 0. And this is our standard form as well. So something a little bit simpler, this is going to be our mother function, y is equal to x, just to start us off. And now let us get ready for the next one. This time we're going to be working with a point and a slope. And we see that we don't really have to do much work with that. So let us do the point -2, 1, with the slope m is equal to 3. So we have the slope, we have the point. There's no reason not to plug it into the point slope. So y minus 1 is equal to 3, x minus -2. Remember, negative times negative, it's going to be positive. So we can just make that into addition. So now we have y minus 1 is equal to 3x plus 2. And then that's it. We have the point slope form. That is going to be one of our boxes. Then to translate that to a y-intercept or slope-intercept, we have to distribute this and then add 1 to both sides. First, let's distribute. So I'm going to add a little arrow there. Y is minus 1 is equal to 3x plus 6. Then we just add 1 to both sides. Gives us y is equal to 3x plus 7. That is going to be our slope-intercept form. Let me just add a little arrow there to show. And then we could translate it one more time to be standard form. Same thing, very similar to the last time. We subtract the 3x to both sides to get x and y at the same side, and a constant alone on the right side. So now we have -3x plus y is equal to 7, making our a -3, b +1, and our c +7. So let us square that as well, as it is our final form. Also, our b here is going to be just 7 as well. And then later, showing that off, it's pretty simple once we have one point and a slope. And let's get into something a little bit more difficult. Well, not difficult, just a little bit more tedious, as we would have to find the slope once more. And let's do with a point 3, 3, and 1, 1/3. Let's put that into our slope formula. So let's just say this is x1, y1. Then let's say the other one's going to be x2, y2. Oops, sorry for my sloppy handwriting there. There we go. So let's just say 1/3 minus 3 all over 1 minus 3, which in the end, this is equal to 9/3. So it's going to be -8/3 over -2/1. I do that just to set up the division of fractions, which we flip the bottom one and then we multiply, and that'll give us the same result. So now it's going to be -8/3 times 1/2, which then gives us -8/6. And then we have +4/3 as our slope. Now that we have our slope, it's going to be very easy to continue with the rest of it. I apologize for my dog barking. Not sure if it's something that could be heard, but if it is, I apologize. So 4 over 3. Now we do the same thing. We choose either the first point or the second point. I would choose the first point just because it's whole numbers and they're a lot easier to deal with. So let's go ahead and do that. Y minus 3, because that's y1, is equal to 4 over 3 x minus 3. And boom, we already have our point slope form. Let's put that in a box. Now let us do the same thing. Let's distribute, then add 3 to both sides. So y minus 3 is equal to 4 over 3 x minus 4, because 4 over 3 cancels out, and minus 4, which then becomes y is equal to 4 over 3 x minus 1. And that is our slope-intercept form. Now to translate this into standard form, we could just do the same thing. Subtract 4 over 3 x and move it across to the other side, which will then give us negative 4 over 3 x plus y is equal to negative 1. And later, that's that. In this part, note that b is equal to negative 1, and our c is also equal to negative 1. Though things can change, it's not always going to be like that, but it's just a nice pattern to see, along with a over here being negative 4 over 3, and b still being 1. And that is all that I have prepared for you guys. Hopefully that was a good review, and if you have any questions, please put a comment down below, and I'll respond as fast as I can. And other than that, thank you for watching, and hope you enjoyed. Alright, bye-bye guys. Have a good day.